Good day once again, and welcome back to my maths class. Today we are looking at maths paper 2 grade 11. Uh, is it 2018? Yes, yeah, 2018 November, right? So this question paper was written by grade 11 learners in 2018. So now let's look at question 7.1. But firstly, before you can attempt to answer any of the given questions, you need to make sure that you read the statement and understand it. Okay, so in the diagram, angle P is 67 degrees and the length PQ is 3 centimeters and PR is equals to 9,2 centimeters as well. So determine the length of QR. So we know the length of PQ, we know the length of PR, okay? So this angle here, which is 67, it is your included angle in this case. And then we spoke about the included angle to say that whenever you have an included angle, it means you can be able to use the cosine rule, okay? So now we are requested to determine QR, right? It means now we are going to say your QR, let me use this space here. Our QR, it is equals to the square root of small letter q squared, this small letter q for 9,2 centimeters, plus small letter r squared. So this is your small letter r squared, the opposite side of this angle, okay? But the opposite side of q, it's small letter q, minus 2qr cos of angle p, okay? So now you can substitute everything that we are given here. So this will be 9,2 squared plus 3 squared minus 2 times 9,2 times 3 cos of angle P, which is 67. So now you are forced to use a calculator. There is no other way. You need to make sure that you use a calculator so that you can get the exact value. So now we are going to say the square root of 9,2 squared plus 3 squared as well, minus 2 9,2 times 3 cos of angle 67 degrees equal to, so you're getting 8,4895. So your answer here, it will be 8,5 centimeters. So basically it was 8,4895. So we are rounding off to one decimal place. That's why we have this 8,5, because whenever it's 8,4895, it means now you can add 1 to this 4 and then it becomes 5. Okay, so now let's look at 7.2. In the diagram below, DCB it is equals to alpha, AC is equals to 8 units, and ACB is equals to theta. So the diagram has been drawn for you guys so that you can refer to the statement that you are given. So 7.2.1, determine the size of angle ACD in terms of theta and alpha. You do not have to stress yourself. You just have to relax in this case, because they are saying that you need to write your answer in terms of theta and alpha. So meaning that you are not going to write the exact value whereby you say angle ACD it is equals to 90 degrees or 180 degrees or any value, but you must write your answer in terms of theta and alpha. So let's check. So the angle that they are looking for, it's ACD. So it's this small angle here, this small angle here that we are looking for. Okay, so now this small angle, since we know that the whole angle of C it's theta, and the angles DCB it's alpha here, so it means that this angle here it is given by theta minus alpha. So this angle, let me just write 7.2.1 here. So our angle ACD it is equals to theta minus alpha, and then you get 1 mark for writing that. Okay, so let's check 7.2.2, but before let me just write theta minus alpha. All right, so let's check 7.2.2. That's saying that you need to prove that AD is equals to H sine theta minus alpha divided by the cos of alpha. So in this case, you just have to check what you are given. This is your H, okay? And then this is theta minus alpha, as you can see here. We're looking for AD, right? So whenever you use your sine rule, it means you're going to have the sin of, or let me say, you must always start with what you are requested to prove. Okay, so let me cancel this sign here. So it means now you are going to start with AD divided by the opposite angle, which is sine of theta minus alpha. Okay, equals to the length of AC, which is H, because here there is H, right, divided by the sine of angle D1. So unfortunately in this case we do not have angle D1 here, but we can determine this angle. So that was the first thing that we're supposed to do, because you cannot be able to proceed with this, because AD is unknown and angle D1 it's unknown. So firstly determine the D1. So our D1, it is equals to 90 plus alpha. 90 plus alpha. This is an exterior angle of a triangle. What? Triangle BCD. Okay. So exterior angle D1 is equals to the sum of the two opposite interior angles. So this is 90 plus alpha. Okay. So it means your angle D1 is 90 plus alpha here. Okay. So now you can come here and substitute 90 plus alpha. Let me use this space this side here. So you are going to say your AD it is equals to H. Here you divide by the sine of theta minus alpha. Here you divide by the sine of 90 plus of alpha. Okay, so now you can make AD the subject. So before you can make the AD the subject, you know that sine of 90 plus alpha, this is confunctions. Okay, so whenever you have confunctions, it means you need to change a sine into cos. So this will be AD divided by the sine of theta minus alpha, which is equals to H divided by the cos of alpha. Okay, so we have changed sine into cos of alpha. Now we can do the cross multiplication. AD cos of alpha, it is equals to H sine of alpha minus a sine of theta minus alpha. Now you divide both sides by the cos of alpha, both sides by the cos of alpha. Therefore AD, it is equals to H sine of theta minus alpha divided by the cos of alpha. Okay, so this will be your answer. Proven. AD, it has been proven that is equals to H sine theta minus alpha divided by the cos of alpha. So this is correct, guys. This is correct. Let's move to 7.2.3. Determine the length of AD if h is given by 17 units, theta is 58, alpha is 23. So you just have to come to the equation that you were proving here, and you substitute what you are given. H, it's 17 sine of theta, it's 58 minus 23 divided by the cos of alpha. Again, the cos of alpha is 23, right? 23 degrees. So now you may use your calculator. So this will be 17 sine of 58 minus 23 divided by the cos of 23 degrees. So I made a mistake. I made a mistake. Yeah. Sorry. Yeah, I made a mistake. So your answer will be 10,6 because this is 10,59, right? So when we round off to one decimal place, it becomes 10,6 units because we are given length in units, as you can see it's h. So now you can determine 7.2.4. For 7.2.4, we are basically looking, basically calculating, calculating the area of triangle ADC, right? So the triangle ADC, it's we know the length of H, which is 17, right? And then we know the length of AD, which is 10,6. Okay. So now we need to look for this angle, the included angle. So it means the theta minus alpha, it's 58 minus 23, which is equals to 35 degrees. So this angle here is 35 degrees. So 90 plus alpha, whenever you add 23 into 90, you are getting 113 degrees. So you need to look for this angle here. So it will be 113 plus 35. 35. So it's 180 minus 113 plus, sorry for that, 113 plus 35. So we are getting a 32 degrees. So the angle here is 32 degrees. So once you have this included angle, you can calculate the area. So your area in this case will be the area of triangle ADC. It is equal to half. We spoke about this, right? Half multiplied by small letter c, multiplied by AC, which is small letter D, and the sine of angle A. Okay, so now you substitute. C is 10,6 times 17 sine of 32 degrees. And then whenever you use your calculator here, let's see what we can get. It's basically half multiplied by 10,6 multiplied by 17 sine of 32 degrees. Okay, so we are getting 47,8 units squared. So your answer must be must have a square there, even if it was centimeter squared or meter squared or kilometer squared. So we are done, guys. This question were very much interesting, so I hope you will enjoy watching this video. Thank you very much.